Hi folks, welcome to the channel. This video is part 2 of the electronic lead screw encoder mount. Today we're going from what you see on the screen to this. This is a continuation of an alternate encoder mount. It's in reference to Clough 42's electronic lead screw YouTube series. If you aren't familiar with this series, be sure to check it out. Also check part 1 of this series, links in the description. This video covers attaching the encoder mount to the lathe. Let's take a look at some of the parts and tools that we'll need. We have some double-sided tape, the encoder mount, 3D printed pulley and alignment tool, number 12 drill, M6 tap, and 4 M6 button head tap screws, and a tap handle. There's a carpenter's level. We have a transfer punch. There's a special socket I made for the spindle lock nuts. Finally, there's some Dicom layout fluid and a laser temperature reader. We're going to start by removing the change gears. I'm using a 6mm T-handle to loosen the change gear set. This allows the set to be rotated out of the way. Next, I'm removing the E-clip from the upper gear. Then I have about 5 minutes of struggling with removing the inner spacers before getting the gear off. Finally, I remove the upper pulley stud. Before removing the spindle lock nuts and pulley, we need to remove the chuck. Sorry about the poor footage. Most of the edited video here is of my back. After we get the chuck off, we're going to push the carriage up against the spindle and lock it. This will help hold the spindle in place. We do this because we want to disrupt the tapered spindle bearings as little as possible. Here we are removing the spindle pulley. I take off the frayed V-belt. This V-belt's on its last legs, and I plan to replace the belt and pulleys when I swap out the single-phase motor for a 3-phase motor in VFD. Next, I use my special socket to remove a not very tight lock nut. The second lock nut turned out to be much tighter, so I messed around for a while using a strap wrench before giving up and tapping on the nut with a pry bar. At least the pulley came off easily. Next, we're going to remove the plastic gear that drives the change gears. This gear gets replaced with a 3D printed pulley. With all of this out of the way, we can get ready to mark the holes for the encoder. The triangular shaped tool is used with the level to position the encoder at the correct angle. It's a job for 3 hands. We rough mark the area with DICOM layout fluid so we can see the drill marks. Here we're applying double-sided tape so we can stick the encoder in position while we mark the holes. I'm afraid I didn't get good video showing me using the alignment tool with the level. I simply got the top of the tool level and then stuck the encoder to the lathe. Here I'm using a 6.5 millimeter transfer punch to mark the holes. Next, we remove the encoder and double-sided tape before drilling and tapping. Now I'm using a center drill to carefully pilot drill the marks. With a center drill, you get better control and accuracy over drill placement compared to using a regular drill bit. The 4 pilot holes get drilled out with a number 12 bit, which is the correct drill size for an M6 tap. I'm drilling carefully here because I don't want to break through abruptly and possibly damage the emergency stop switch. Next, the 4 holes are tapped with an M6 tap. I'm using a spiral tap, which is my preference because oftentimes you can power tap with them. Off camera, I slid the 3D printed pulley over the spindle. And here I'm mounting the encoder. I just need to tighten the M6 screws and then adjust the belt. Now the pulley goes back on, followed by the lock nut. I initially tightened down the lock nut to take the slop out of the spindle. The lathe chuck is still off at this point. Off camera, I've put the chuck back on, and I'm keeping the spindle from moving by using a crescent wrench on one of the jaws. To set the bearing clearance, I'm going back and forth between tightening the nut and giving the chuck a spin. I'm looking for the chuck to turn about a quarter to a half turn when I spin the chuck with a moderate amount of force. If the bearings are too loose, the chuck will spin too much, like 3/4 to a full turn. And if too tight, the chuck will barely spin. I'm happy with that, so the last things to do are to put the second lock nut on and the V-belt. Well, that's about it for this video. I hope you find it useful. If you like, please leave a comment with any suggestions. Thanks for watching. Take care.